Okay, we're at section 7.3. We're going to take a mathematical detour for a bit and talk about the scalar product of two vectors. Now, if you look at the equation here, you'll see that A is a vector. It's got it's bold face and it's got the arrow above it. And B is a vector. And you'll see that you get it's defined as the magnitude of A times the magnitude of B times the cosine of the angle between them. This is what we've been using for to get work. Force times distance times the angle between them. So this operation has a specific name. It's called the scalar product. Later on, we'll learn about the vector product. The scalar product, two vectors multiplied together. Using the scalar product, you get a scalar. And the vector product, two vectors multiplied using the vector product, you get another vector, hence the names. This is also called the dot product, A dot B, the dot product. So AB cosine theta, so you can see that the work is equal to F dot delta R. So the force times the displacement times the angle between them, that's equal to F dot R. Now, let's look at the mathematical meaning of this. You have, if you look at the diagram, you have the A vector, you have B vector, and there's an angle theta between them. You'll see that the B cosine theta is the projection of the vector B onto A, and the result is the magnitude of A times the magnitude of B times the cosine of the angle between them. Now, the dot product or the scalar product is commutative. A dot B equals B dot A. It's also distributive. A dot B plus C is equal to A dot B plus A dot C. So it is distributive. Now, what is the cosine of 90 degrees? Well, the cosine of 90 degrees is equal to 0. So if when A is perpendicular to B, A dot B is equal to 0. Why? Because the cosine of 90 degrees is equal to 0. So whenever if you recall in the last, when we were showing you the picture of the eraser, pushing down on the eraser, the dot product there was 0. You get no work done because the force isn't causing any displacement. So when two vectors are 90 degrees, your scalar product is 0. Now, when they're in parallel, the cosine, now you'll see that there's two ways that vectors can be parallel. One, there's 0 degrees between them, and one, or there's 180 degrees between them. So we'll look at these two situations. So if A is parallel to B and it's in the same direction, then theta is equal to 0 degrees. So A dot B in this case is equal to AB. Well, what if it's 180 degrees? That's a way of being parallel. Well, what is the cosine of 180 degrees? It's equal to -1. So the two vectors that are parallel but 180 degrees from each other, the scalar product is minus AB. Now let's look at it in terms of unit vectors. We have the orthogonal unit vectors I, J, and K. I is perpendicular to J, J is perpendicular to K, and K is perpendicular to I. They're all orthogonal. There's 90 degrees between them. So if you do the dot product between any one of them, they all equal to, in other words, I dot J is equal to 0. And that should be probably J dot K in the middle. I'm looking at this one here that I didn't notice that before. So it's I dot J equals J dot K, or I dot K equals J dot K. They all equal 0. In other words, if you're doing a scalar product between unit vectors that are orthogonal, they're all going to be 0. However, if I dot I, well, the cosine of the angle between I and I is 0. So I dot I equals J dot J equals K dot K equals 1. They're all, it's a univector, so the magnitude is 1. So 1 times the cosine of 0, which is 1, is all equal to 1. If A is equal to AX, AXI plus AYJ plus AZK, and B is equal to BXI plus BYJ plus BZK. If you multiply that out with the dot product, all the I dot J, J dot K, and K dot I, they'll all go to 0, but all the I's will end up equal 1. So the solution to A dot B is equal to AXBX plus AYBY plus AZBZ. And if A happens to be equal to B, you can substitute A dot A is equal to AX squared plus AY squared plus AZ squared is equal to A squared, basically. Okay, which of the following statements is true about the relationship between the dot product of the two vectors and the product of the magnitudes of the vectors? So the product of the magnitude is just the absolute value of A times the absolute value of B, which is AB. A dot B is larger than AB. Well, what is the range of values of cosine theta? Well, it varies between -1 and 1. So it's never like 1.1 or 1.5. So A dot B will never be larger than AB. A dot B is smaller than AB. Well, if it's if the cosine theta is equal to 1, then it's equal. So it could be smaller, but it isn't always smaller. It's smaller by a cosine theta term, but it's not guaranteed to be smaller. A dot B could be larger or smaller than AB depending on the angle between the vectors. Well, we discussed in A that the cosine theta varies between -1 and 1, so it'll never be larger, so that couldn't be it. So A dot B could be equal to AB. So the scalar product could be equal to the product of their magnitudes if theta is equal to 0. And let's see if I'm correct. Yes, A dot B could be equal to AB. And let's see. Okay, that's the end of section 7.3, and we'll go on with 7.4 in the next lecture.